Hello class, welcome to this video on the EOC review practice. So this is part 3 of the series. So we're going to try to finish up the rest of the questions. Again, just a disclaimer, this video will be long just because of the sheer number of questions we got to deal with. So for the standard here, we have derive using similarity the fact that the length of the arc intersected by an angle is proportional to the radius, and define the radian measure of the angle as the constant of proportionality. Derive the formula for the area of a sector. All right, so for number 1, what is the area of the sector MTN? So this little chunk here of the circle. Now the formula for the area of a sector is the angle, the central angle here, which is the same as the arc right here, the measure of the arc, over 360 times pi r squared. And there's your formula. And so in this case, the angle is 42. So we got 42 over 360 times pi times the radius, which is 8 squared. And so you get 42 over 360 times 64 pi. Now you can, of course, reduce a bunch of stuff. You could say that, let's see here. For this case, we can say that all right, so we'll go ahead and see what goes into 64 and reduce the fraction here. So we'll do this on the calculator. So let's see, 360, so 64 divided by, so 4 goes into 64 16 times, and 4 goes into 360 90 times. And then 16 divided by 2 is 8, and then divided by 2 here is 45. All right, so and then we can take that and basically reduce 42 over 45. So in this case, 3 goes into 42 14 times, and 3 goes into 45 15 times. And then finally we have 14 times 8 is 112. So we get 112 pi over 15. And there's my area for my sector. Okay, so just reducing that fraction as much as we can. So for number 2, in circle Z, the measure of angle PZR is 2 pi over 3 radians. So 2 pi over 3 rads, which means that the arc is 2 pi over 3 rads as well. So this arc. So we want the length of the arc. We got the measure of the arc, right? The arc measure. This time we want to find the arc length. The formula for the arc length in radians is the radius times the angle. And this angle has to be in radians for this to work, okay? So it's going to be the radius, which is 8, times that angle, which is 2 pi over 3. And that's it. So we get 8 times 2 is 16. So 16 pi over 3 is your response. For number 3, in the diagram below, the circle shown has a radius of 10. Angle B intercepts an arc with a length of 2 pi. So we got our arc length here. And they want to figure out the measure of B. So S is equal to 2 pi. The radius is 10. So remember that S is equal to R theta. We'll write it over here. And so that means that theta is S over R. And S is 2 pi, and the radius is 10. So this reduces to 1 over 5. So it would be pi over 5 is the measure of angle B. So now for number 5 here. If the area of the shaded part of circle K is 15 pi over 15 over 2 pi, what is the value of X? So we want the radius essentially. And so let's go ahead and they give us the shaded part right here. The shaded part has to be 300 degrees because the entire circle is 360 and this part already is 60. So 360 minus 60 is going to give us the 300. So now we know our angle for the shaded sector is 300. And remember the formula for the area of a sector is theta over 360 times pi r squared. And this is when it's in terms of degrees, not radians. So since we're dealing with degrees, we're going to use this formula. So we get 300 over 360. And we know that the area is 15 pi over 2. So we're going to write that down on the left side. And r here, the radius, is actually x. So we're going to call that x squared there. All right, so We know that 60 goes into 300 5 times, and 60 goes into 360 6 times. That's really 5 over 6. So we get 15 pi over 2 is equal to 5 pi over 6, and then x squared. We're going to get rid of this by multiplying by 6 over 5 pi, multiplied by the reciprocal to cancel out. Do that here as well. So now we got the pi's cancel. 15 divided by 5 is 3, and then 6 divided by 2 is 3. 3 times 3 is 9. So we're left with 9 is equal to x squared. Take the square root of both sides, and therefore x has to be 3. So there you go. We got the value of the radius. So for number 5, an arc on a circle of radius 10 has an arc length of 49 pi over 9. So that's our S, and that's our R. What is the measure of the corresponding central angle? So we want to find theta. If the radius is reduced to 2, is an arc length of 49 pi over 9 still going to be possible here? Okay, so let's go ahead and calculate the corresponding central angle first. So remember that S is equal to R theta when theta is in, when the arc length here, well, yeah, let's do it in terms of radians. Just to make it easier for us. So, no, actually, let's actually do it in terms of degrees. It might be easier if it's in terms of degrees. So we got, no, let's actually do it in terms of radians because we have it in terms of pi here. So let's do it that way. Okay, so the arc length is 49 pi over 9, and the radius is 10. And so you're going to divide by 10 on both sides to get rid of it. This is the same thing as multiplying by 1 over 10. So that's what I'm going to do, where the 10 is on the bottom, so it cancels. So I'm going to multiply by 1 over 10, and 10 times 9 is 90. So this is going to be 49 pi over 90 is equal to theta. And so there's my central angle. Now to answer the second part, if the radius is reduced to 2, so now the radius is going to be 8, is an arc length or it's reduced to 2, so the radius is now 2, sorry. Is an arc length of 49 pi over 9 still possible? So let's go ahead and plug it in. 49 pi over 9 is equal to, the radius is now 2, and then we got theta, so we'll multiply by a half to cancel. So this now becomes 49 pi over 18 is equal to theta. So is this possible? Well, 49 pi over 90, if we were to plug that in, and in fact, well, let me actually do it over here. So 49 times pi over 90. So that's 1.71 radians. Remember that a full circle is 2 times pi radians. So a full circle is 6.28. And so far we only got 1.71. So this is not even half of the circle. Now let's go ahead and do it if it's 49 pi over 18. If you did 49 pi over 18, then that's actually over a circle. So 49 pi over 18 is 8.55, which is greater than 6.28. So this is actually greater than 2 pi radians, which means that it's a full circle, which means it's not possible to get an arc length when you have a full circle. So this is not going to be possible because we're going past a full circle. It's not going to be possible if the radius is reduced to 2, where the angle is greater than 2 pi. All right, so for number 2, or I guess it's number 6 here, 3 concentric circles with center O. So we're given 3 concentric circles. These are circles that have the same center, and they're inside. One is inside the other, and so on. They said that KL is congruent to LN, is congruent to NO, is congruent. So these are all congruent, essentially. KP is 42. So they tell us that the diameter is 42. Okay, well, if that's the case, then that must mean that we could do 42 divided by 7, and that'll give us the distances there. So it's going to be 6. So each of these are going to be worth 6. Okay, so now I'm going to get rid of this 42 because we don't need that anymore. And we know all of that information. So those are all 6, those distances. Okay, so let's go ahead and find the area of the shaded region. Now, if we want to find the area of the shaded region, what we need to do is take the find the area of the circle on the outside, the entire area, and cut it in half. So essentially, we're trying to figure out this entire area for the big circle. And then once we do that, then we can subtract out the area of half of this circle, right? Subtract this half out, and that will give us a shaded region, okay? So that's exactly what we're gonna do. So the area, the area of the shaded region is the area of the half circle, okay? So this is for the semicircle in red, semicircle 1, minus the area of semicircle 2, and that's going to be in purple. Okay, so let's go ahead and do the area. So we have that the area of semicircle 1, well, it has to, remember that the area of a circle is pi r squared. So it's going to be 1/2 pi r squared for a semicircle, right? Half of a circle. Okay, so the radius of the big red circle is 18, right? 666. So 6 times 3, essentially. Hold on a second. It's not 6. It should be 42 inches for the whole thing, divided by 1, 2, 3, 4, 5, 6 parts. That's 7. Sorry, not 6, but it's going to be 7. Apologize for that. So it's going to be 7 on each side. And therefore, it's going to be, so we got radius squared is 7. And then minus 1/2 pi. This is for now for the purple one, so let me change the color coding there. And the purple one is just radius of 7, so times 7 squared. And there you go. And then now you can factor out the 1/2 pi if you'd like. You could factor it out. And then we got 7 squared minus, or not 7 squared, 7 times 3 is 21, so 21 squared. Sorry for these little mistakes here. And then 7 squared. There you go. That makes more sense. And so then we go ahead and figure out what this is. It turns out when you do this, you get 392 pi over 2, which is 196 pi, which is approximately 616 square inches. And there you go. So it's going to be D. All right, so let's look at the next standard. Given an informal argument for the formulas of circumference, area of circle, volume, and so on, use dissection arguments and Cavalieri's principle and informal limit arguments. So this standard is mostly on Cavalieri's principle. So 2 stacks of 23 quarters are shown below. One stack forms a cylinder, so it's a nice perfect cylinder, but the other stack does not form a cylinder. Use Cavalieri's principle to explain why the volumes of these 2 stacks must be equal. Okay, so remember that Cavalieri's principle states that if you are to slice this at each level, so if I were to slice it at this level, and I'm only looking at, then that means I would only be looking at one of the quarters, right? So let's assume that we slice it so that we're only looking at 1 quarter at a time. As long as the coins here are the same cross-sectional area, meaning that they're the same coin, they're both quarters, right? So if I do this for every slice, if I do this for every single level, right? For every single thing, I'm only going to have 1 quarter at a time. Notice that the cross-sectional area does not change as I make this slice. And if I do this and the areas are always going to be equal in each level, and the heights of these stacks are the same, which the heights are, then that means that the volume must be the same, okay? So I always liken it to a stack of pancakes. If this were a stack of pancakes and the other one were a stack of pancakes kind of loosely positioned, it'll still take up the same amount of space in my stomach, all right? Because it has the same volume. All right, so use Cavalieri's principle to explain this. So the areas of each cross-section at every level are, and the radius is going to be pi r squared, right? If the radius is r, then it's still going to be pi r squared, and the radius is the same for both of them. And the height of both stacks are the same. Therefore, the volumes are equal. And what is the formula for the volume? Well, we know that each cross-sectional area is pi r squared, and there's the height is h, so the volume must be pi r squared h for both cylinders, for both figures, even though the right one is not a cylinder. Okay, so according to Cavalieri's principle, under what conditions are the volumes of two solids equal? And we said that earlier, when the cross-sectional areas are the same at every level and the heights are equal. And there you go. So number 3, Alejandro cut a circle with circumference C and radius R into 8 congruent sectors and used them to make the figure shown. So he had a circle with radius R, and he cut it into 8 pieces, essentially like that, and the radius is R. And then he lined them up like this. Okay, so Alejandro noticed that the figure was very close to the shape of a parallelogram. If you look at it, it almost looks like a parallelogram. All right, so select all the statements that apply. So since it's very close to a parallelogram, let's see what the area of this parallelogram would be, right? If we were to calculate the area. Well, let's see. We know that the circumference of a full circle is 2 pi r, right? And so that must, and then we know that the area of a circle is well, let's go ahead and calculate the area of this. We know that the area of a parallelogram is base times perpendicular height. Perpendicular height, we're going to find. Well, we know that the perpendicular height must be the radius, approximately, right? Because this is approximately the radius of the circle, right? That little sector there. So that's going to be approximately the radius is the height. Or this right here is approximately the radius, rather. So this right here is my radius. And that is approximately the height of the parallelogram. So we're going to say that the height is approximately the radius, okay? And as far as the base is concerned, that's our base right there. As far as the base is concerned, well, we want to note that when you cut out all of these sectors, right, and you place them side by side, notice that they're placed in a row, which means that the sum of these two parts must be the circumference of the circle, right? Because if I were to take each of these sectors and add them all together, they should make the full circle, right? This sector, this sector, this sector, and there's 8 of them. And I only got 4 here, which means that the length of this parallelogram is approximately equal to the half of the circumference, okay? And so there's your formula, okay? So there's our guy. So our area of the parallelogram must be half of the circumference times the radius. And so remember that the circumference is 2 pi times r, right? So we got 2 pi r over 2 times r, and the 2's cancel. And so we got pi r times r, which is pi r squared. And this is approximately, it's not exact, because as we said, the radius is not exactly equal to the height, and this is not exactly, this red is not exactly equal to this green, but it's approximate. So we get the area of a circle. Interestingly enough, we use this to estimate the area of the circle. So select all the statements that apply. The height of the parallelogram is approximately equal to the circle's diameter. No, we said that it's equal to the radius, not the diameter. The area of the parallelogram is approximately 1/2 CR, and that's what we said here. It's approximately 1/2 times the circumference times radius. So that's true. The length of the parallelogram is approximately equal to the circle's circumference. No, it's approximately equal to half of the circumference, not the circumference. The radius of the circle is approximately equal to the height. Yes. The area of the parallelogram is approximately 8 times that. What is all that? Well, there's 8 sectors, and each of the sectors must be 45 degrees, because if you look at the circle here, if I divide it into 4 pieces, these must be 90 degrees. And then if I cut those pieces in half, they're going to be 45 degrees each. So it's just saying that they're 45 degrees each. The theta is 45 for each sector over 360, and there's 8 of them. So yes, this is true. The area of the parallelogram is approximately equal to that. And remember that if I were to simplify that, this actually turns into pi r squared anyways. So if I were to multiply these together, that would become 1. And 1 times pi r squared is pi r squared. All right, so there you go. That takes care of that question. That was a very interesting type of question. So number 4, 2 cylinders, a sphere, and a cone are shown. Select the 2 objects with the same volume. So we'll just calculate volume. So the volume of a cylinder is pi r squared 8 times h. So you need the area of the circle, and then you multiply by the height of the cylinder. So we got pi, and the radius of the cylinder is half of that, so it's 1.5 centimeters. So 1.5 times the height is 4, and don't forget that the radius is squared. All right, we'll leave that alone for now, and we'll end up calculating. Actually, let's do that now. This will turn into 9 pi, and then we'll compare the. We're not going to do it as a decimal. We'll leave it as a in terms of pi. Okay, so let's give it a sec here. This is going to be 9 pi. And so let's do the cone. So the volume of the cone is 1/3 pi r squared h. The cone is, there's always 3 cones that can fit in a cylinder that's, has the same radius. So we got 1/3 pi times 4 squared. That's the radius is 4. The height is 2. And so when we do that, we get 32 pi over 3. Now for the sphere, the radius of a sphere, we know that the radius the radius is 2, half of this diameter, but the volume of a sphere is 4/3 pi r cubed. And the radius here is 2, so it's going to be 2 cubed. When we multiply that, we get 32 pi over 3. And then finally, for the cylinder here, it's pi r squared h. Pi times the radius is 1, and the height is 6. So it's going to be 6 pi. So if we compare these, we can see that the cone is actually the same volume as this sphere. Interestingly enough, this cone is actually large enough so that it actually fills the same amount of space as this smaller sphere here. All right, so looking at the next problem, we're moving to the next standard. Use volume formulas for cylinders, pyramids, cones, and spheres to solve problems. So the figure shows the shape of a piece Julia is welding together for a sculpture. What is the volume of the figure? So we have a hemisphere, a cylinder, and a cone. So the volume, the net volume, is the volume of the hemisphere plus the volume of the cylinder plus the volume of the cone. So let's note that the radius of this hemisphere is actually 2, right? It's not 4 because the 4 is the diameter. And the radius of this cylinder is also going to be 2, right? So the radius of the cylinder and the cone, the radius of all these, the radii, is going to be 2. And if this is 2 and this is 12, and this whole thing is 21, right? Then this must be, the height of the cone must be 21 minus 12 minus 2, right? So you got to subtract this part and subtract the part from the hemisphere. And so if you did that, you get that the height of the cone is actually 7. So we're going to need that later. All right, so the volume of the hemisphere is 2/3 pi times r cubed. R is 2. The volume of the cylinder is pi times r squared. So 2 squared times h, the height of the cylinder is 12, plus the cone 1/3 pi times radius squared times the height, which we found is 7. So when you do this on the calculator, you get approximately 196.9 units cubed. And so its answer is going to be B. All right, so number 2, the weight of helium in a balloon can be estimated by calculating the volume of a sphere with the same diameter as the balloon's width. Helium has a density of about 1.165 ounces per feet cubed. What is the weight of the helium in a balloon with width 10? So the balloon has a width of 10, which means that the diameter is equal to 10 inches, which means that the radius is 5 inches, right? So we're going to be using that to help us out. Also, we want to make sure that we convert it to feet because this is in feet cubed. So let's convert radius of 5 to feet. So we're going to do 5 inches, and remember that there's 12 inches in 1 foot. And I put the 12 inches on the bottom to cancel. So this is going to be 5 over 12, which is So we'll do that on the calculator here. So 5 over 12, so it's approximately 0.42 feet. All right, just rounding that. So now we got the radius in terms of that. So this is approximately 0.42. And so now they tell us that, remember that the formula for density is mass over volume. So it says here, we don't know the volume yet, but we can calculate the volume. So let's do that right now. The volume of the balloon is based off of a sphere. It's 4/3 pi r cubed. The r is going to be 0.42 cubed. And if you did this, you get approximately 0.31 feet cubed. And then we can plug that in for the volume. And we know that the density is 0.165, so we can plug that in for the density. So when we do that, we get 0.165 equals mass over 0.31. Multiply both sides by 0.31 to cancel. And you get that the mass, when you multiply those two numbers together, is approximately 0.05 ounces. The units are going to be in ounces here. So not much helium is actually very light. All right, so for number 3, a cylinder has a volume of 300 pi cubic centimeters and a base with a circumference of 10 pi. So we need those two. So remember that the volume of a cylinder is pi r squared h. The circumference of a circle is 2 pi r. They give us 10 pi here, so let's plug that in for the circumference. And if you solve this and divide by 2 pi on both sides, you get that the radius is 5. So now we got the radius is 5 centimeters. We can plug that in for here. And we know that the volume is 300 pi. We can plug that in for there and get the height of the cylinder. So we have 300 pi is equal to 25 pi, 5 times 5. We can divide by 25 on pi on both sides. Pi's cancel. 300 divided by 25 is going to be 12. So h is 12 centimeters. All right, so number 4, the diameter of a basketball is approximately 9.5 inches. The diameter of a tennis ball is approximately 2.5 inches. So the radius, let's call this item sphere 1, and let's call this sphere 2. So the radius of sphere 1 is 9.5 over 2, which is 4.75 inches. The radius of sphere 2 is 2.5 divided by 2, which is 1.25 inches. Now the volume of the basketball is how many times greater than the volume of the tennis ball? Well, the volume of the basketball of sphere 1 is 4/3 pi times the 4.75 cubed. And the volume of the tennis ball is 4/3 pi times the volume of the radius of the tennis ball cubed. Okay, so we're gonna just leave it like that, and we're gonna see how much bigger is that than this. So in order to do that, we need to divide those, right? So if V1 were 10 and V2 were 2, 10 divided by 2 would be 5, and it would be 5 times greater. So we just got to take the ratio. Okay, so it's going to be 4/3 pi times all of this, and 4/3 pi times all of that. And the 4/3 pi cancels, so that's nice. So leaving you with the radii cubed. And if you did that, you're going to get, let's see here, do it on the calculator. We get approximately 55. And so that means the ratio of V1 to V2 is 55. So that means V1 is 55 times greater than V2. So that means the basketball is about 55 times greater than the tennis ball, the volume. All right, so it says here, Jeff is mailing a jar of jam to his grandmother. He finds a rectangular box just tall enough for the jam. Which expression represents the volume of the box that is not occupied by the jar? So we just want the volume, the space that is left over. So we need to basically subtract the volumes. So subtract the volume of the box. Well, subtract the volume of the cylinder from the box. So we need the volume. The volume remaining is the volume of the prism minus the volume of the cylinder. Now the volume of this prism is 15 times 10 times h, right? So 15 times 10 times h minus the volume of the cylinder is pi r squared. So it's pi times 5 squared times the height, which is h. And so you get 150h minus 25 pi h, which is the same thing as this. If you factor out the h, you get 150 minus 225 pi, which is the same as that. All right, number 6. Alex is shopping for cheese. She noticed that the cheddar and brie have the same volume, but even though their shapes are different. Based on the diagrams, what is the width W of the brie cheese? Okay, so we know that. So it says they have the same volume, but their shapes are different. All right, so same volume. So the volume of the cheddar is equal to the volume of the brie here, brie cheese. And so the volume of the cheddar is 3 times 4 times 1. Or times 10, sorry, not 1. And the volume of this other cheese, this is a triangular prism. So the base, remember that the volume of a prism is BH, capital B, where capital B is the base area. So the base area is it for a triangle. So a triangle is 1/2 little b little h, 1/2 base times height. This is the base and this is the height. Or vice versa. And then the h is the capital H for the prism is 10. Okay, so let's call this B, let's call it W, and then the height of the here is 3. So this is going to be 1/2 W times 3 times 10. And so half of 10 is 5, and then 5 times 3 is 15. So this is going to be 15W, and this is 3 times 4 is 12, times 10 is 120. So divide by 15 on both sides to get W. And you get that W is 8 centimeters. All right, so for the last one here, it says a grain storage silo consists of a cylinder and a hemisphere. The diameter of the cylinder and hemisphere is 20 feet. The cylinder is 100 feet tall. What is the volume of the silo? So we're just looking at this part here and just finding the volume. Okay, so the radius has to be 10, which is the same as the radius of the cylinder as well. So I'll just do it here. All right, so the total volume, or the net volume, is the volume of the hemisphere plus the volume of the cylinder. And the hemisphere is 2/3 pi times radius cubed, plus the cylinder is pi times radius squared. Oops, not that squared. The radius is 10 times the height. Okay, so we'll go ahead and multiply those together. And so if you did this, you got the 10 cubed is 1,000. 1,000 times 2 is 2,000. So you get 2,000 pi over 3. And then 10 squared times 150 is 15,000. So this becomes 15,000 pi over 1. So this is over an invisible 1, so we need a common denominator of 3. So I'm going to multiply by 3 top and bottom. And then so I get 2,000 pi over 3 plus 15,000 times 3 is 45,000 pi over 3. Then you add those numerators together, you get 47,000 pi over 3. And there's my volume of the silo. Okay, so next standard, identify the shapes of 2-dimensional cross-sections of 3-dimensional objects generated by rotations of 2-dimensional objects. So for number 1, a plane intersects the regular octahedron shown through its top and bottom vertices, which best describes a cross-section formed. It also must be noted that it's not listed on the diagram, but we're assuming that this height is actually half of the base of the this central part. Okay, so this here is B from here to here. It's not listed on the diagram, but this is what we assume, and the height is B over 2. All right, so so there we go. So let's go ahead and find the plane intersecting. It says a plane intersects to the top and bottom vertices. So that must mean that you have a plane, a flat plane. It's slicing this in half, and it's slicing it through those two. So if I slice it through those two, and this is actually, it's hard to kind of show that, but let's do this so that it's at an angle like that. It's slicing it halfway. So it's going to be slicing it so that the cross section meets the vertices like so. So that right there is my cross section. And what is that cross section exactly? Well, let me go ahead and redraw it here. So there's my cross section, and it looks like a parallelogram. And in fact, it is a parallelogram. What kind of parallelogram though? So it's definitely not a trapezoid, hexagon, or triangle. So we can, by process of elimination, we could show that it's a rectangle. But let's go ahead and show you why this is the case. Well, in here, if we assume that this is half of the base, well, this right here has to be half of the base, right? B over 2, it's half of this red. And so you get B over 2 and B over 2. So that means this must be a 45-degree angle. If these two sides are the same, remember for a 45, 45, 90 triangle, if the heights are the same, then it must be a 45, and it's a right triangle, then it must be a 45, 45, 90, which means this is 45 and then another 45 to make this into a 90-degree angle. So these are all actually 90 degrees. And therefore, we have since we have a parallelogram with right angles, it must be considered to be a rectangle. And in fact, this is actually a square, more specifically, because these are all the same distance, because it's a regular octahedron. But in any case, it's a rectangle, and a square is a rectangle. So this meets the criterion. All right, so for number 2, a rectangle is rotated about one of its sides. What three-dimensional figure is generated? So we have a rectangle. I'm just going to draw a skinny rectangle here, and it's rotated about one of its sides. So this side right here. So this is my axis of revolution. It's rotated around it. And if I rotate that around it, notice that I get this cylindrical shape, so it makes a cylinder. All right, number 3, choose the space figure formed by rotating each solid about this axis of rotation. Okay, so if I take this and I rotated it around, then notice if I do that for every single part here, using, with the same distance across, then it makes a hemisphere. So this right here must be a hemisphere. All right, if I take this shape and I rotated it, notice that it makes a conical shape, a cone shape. So this makes a cone. And we talked about this one earlier. If I rotated this like that, then it makes a cylinder. And the cylinder is going to be half of the base. The radius of the cylinder is half of the base of that rectangle. But in any case, it's a cylinder. All right, so for number 4, select all the polygons that can be formed by the intersection of a plane and a cube. This one's pretty interesting, and it could be difficult if you're having a tough time visualizing. However, we'll try to make it as simple as we can. So we can definitely form a triangle if we intersected it so that the plane crosses these 3 points. So we can make that cross section. That's possible. So you can make a triangle. We can also make a square. So if I were to slice it, like this way, right? Then that would be a square, right? So that makes sense. We can also, so this is okay. The first 2 are okay. We can also make a rectangle if we slice it so that the plane slices it this way, diagonal, where we have these 4 points here. That makes a rectangle. So that looks good so far. And then let's look at a pentagon. Well, the pentagon, we can slice it in such a weird way that we get, say, these points, and then maybe this point, and then we can get this point, right? And we can make a 1, 2, 3, 4. That would be more of a 4-sided shape. Let's do one more. So 1, 2, 3, 4, 5. Oh yeah, these are going to be 5 vertices. So yeah, that should be okay. So we got 1 here, we got 2, we got 3. And actually, that's a little bit odd. So let me try to draw a little bit better. So, and it doesn't really matter where the points of the shape is going to be. We just want to know 5 points on this. So 1, 2, 3. Maybe there could be a point here, 4, and maybe a point here, right? It doesn't really matter too much as long as you're making the trapezoid. So hopefully you can kind of see that trapezoid there. And there is a plane that exists that you could make a trapezoid, or not a trapezoid, a pentagon. you only need the 1 point. You can actually make this point right here and make the pentagon shape like that, right? Rather than, so anyways, in any case, you could make a pentagon and you could do a hexagon because you have 6 corners that you could do this with, right? 6 points on the space that you can do this with. So bottom line, you can do hexagon, pentagon, rectangle, square, triangle, but you cannot do an octagon because there are only so many faces that you can do it with. There are only 6 faces in a cube, right? And so there's only 6 potential spots where you could place a vertex. So you can do up to 6 spots. All right, so number 5, what shape is the cross-section formed by the intersection of a cone and a plane parallel to the base of the cone? So we have a cone, which the base is a circle. If I slice parallel to that base, so like that, well then notice that I get a circular cross-section, and so it's going to be a circle. All right, so which figure has the same cross-section of the sphere? Well, if I slice this parallel, then that's going to be a rectangular cross-section. If I slice this parallel to its base, I get a circular cross-section, and we know that a sphere, if I slice it parallel, I get a circular cross-section. So there you go. The answer is B. Number 7, Erin drew a 3-dimensional figure with an interesting plane to show a circular cross-section. She then noticed that all cross-sections are parallel to the one she drew would also be circles. What additional information would allow you to conclude that Erin's figure was a cylinder? Well, for a cylinder, if I were to do a bunch of cross sections, and if I were to slice it a bunch, parallel a bunch of different ways, right? I would get a bunch of circles, right? And these circles must be the same radius, the same area, the same shape, right? And so in order for this to be a cylinder, these cross-section areas must be the same. And so they basically must be congruent, right? Now, if I were to do this for a cone, notice that the cross-sections are also circles, right? If I were to do a cross-section here or a cross-section here, so that's a circle, but this is a circle. However, those circles are not congruent. They're similar, but they're not congruent. So for a cone, the circular cross-sections are similar. For a cylinder, the circular cross-sections are congruent. So for it to be a cylinder, the circular cross-sections must be congruent. All right. So derive the equation of a circle of a given center and radius using the Pythagorean theorem. Complete the square to find the center and radius of a circle given by an equation. So that's the next standard here. So we have an equation in general form, and so we want to complete the square here. So essentially what we're doing is completing the square, and I'll remind you of how to do that in case you forget. So let's go ahead and go to the problem. First thing you want to do is move the constant over to the right-hand side. Get all the variables to one side. Okay, so then I'm going to group these together like this, all right? And I'm going to leave some room. So we got 4x squared minus 16x plus, leave yourself some room to complete the square, plus 4y squared minus 24y plus, leave yourself some room to complete the square, is equal to negative 16. All right, so let's complete the square. But before we do that, we need to make sure that this needs to be pulled out, okay? There should not be a number in front of that or before that x squared. So we're going to pull that out. We're going to factor the 4 out here and here. If I factor the 4 out here, I got to factor it from the 16. So I get 4 times... Okay, so if we pull the 4 out, we get... so if I do that, I get 4 times x squared. And then remember, if I pull 4 from 16, that's going to be a 4, because 4 times 4 is 16. Plus, and then blank. And then we're going to do the same thing here. 4 times y squared. If I pull 4 from a 24, then it's really 24 divided by 4, which is 6. And then blank equals negative 16. All right, so now we're ready to complete the square. We are going to fill in the blanks here. Now, to fill in the blanks, we take the middle number divided by 2 and then square it, okay? So that's the shorthand version of it. There's a whole another explanation that I can give, but this is to save time. The shorthand version is take the middle coefficient, the coefficient of x, divide that by 2 and square it. And that's going to give you 4, okay? So we're going to plug that in here. So that's completing the square there. And then for here, we're going to take that middle coefficient, that negative 6, and divide it by 2 and square it. And that gives us 9. So there you go. All right, so now we got 4 times 4 is 16, right? So because that's 16, technically we added a 16 here. I didn't just add a 4, I added a 4 times 4. So I need to, if I add something on one side, I got to add it to the other side. So I got to add a 4 times 4 here. Okay, be careful, don't just add a 4. This is actually worth 16, not 4. And this is not just 9, this is 4 times 9 because of this thing that needs to be distributed later on. Okay, so keep that in mind. So we added a 4 times 9, so I'm going to do that here. And so if I add this on the right-hand side, I am going to get 36. Okay, so there you go. So now we're going to factor this. So if I were to factor that, well, I need the factors of -4 to add to 4. And you would tell me, hopefully, that it's going to be -2 and -2. Because they multiply to 4, but they add up to -4. Sorry, the 4 should be on top, and the -4 should be on the bottom. They multiply to the top, but add to the bottom. And so this is going to be 4, and then parentheses, there's 2 of these. So x minus 2 and x minus 2, which is the same thing as x minus 2 squared. So there you go. Plus 4, and then let's factor this. So I need the factors of 9 to add up to -6. And that's going to be -3 and -3. So it's going to be y minus 3 squared is equal to 36. Okay, so now we're going to divide off this 4 because we don't want that there. And so these cancel, and this is going to be 9. So we get x minus 2 squared plus y minus 3 squared is equal to 9. So there, that is my standard form of a circle, of the equation of a circle. The standard form, remember, is x minus h squared plus y minus k squared equals r squared. And there's your standard form, and it looks exactly like that. The hk tells you your center. So your center is given by hk. So h, if the signs match, then it's going to be positive. So the h is going to be positive 2. The signs match here, so it's going to be positive 3. If the signs do not match, it'll be negative. So my center is 2, 3. My radius squared is 9, which means that my radius is square root of 9, which is 3. So my radius is 3. And there's my center and radius of my circle. All right, so that was a lot of work to get the center and the radius. All right, so next question is the center of a circle is at -5, 7, and its radius is 6. Derive the equation of the circle using the Pythagorean theorem. Okay, so what we're going to do is we're going to kind of just quickly draw this circle. And in fact, since the center of the circle is at -5, 7, and the radius is 6, I'm going to just bring this down a notch. Okay, so we got -5, 7 is my center. And the radius is 6. So it's going to be 6 away from the center on either side. And 6 up and then 6 down. And so it's not a very good circle, but you know, you get the idea, just for graphic sake here, just so that you can get a visual. And so yeah, so the radius is 6. So because the radius is 6, let's pick a point on this circle. And let's call that point xy. And so the radius here is given in green. It's going to be 6. And let's call this x and this y. So notice that this makes a right triangle. And so we can use the Pythagorean theorem here. Now we know that the center is -5, 7. And so what we can do is, to get this blue part, we have to take this coordinate minus this coordinate to get this distance here. Okay, so this, because remember this, like for example, if this distance were 5, then, and this were -5, then it would be, the distance between -5 and 5 would be 10. Okay, so we just have to subtract those two coordinates. So we get x minus the -5, that becomes x plus 5. And the distance for the y coordinate, you take the y coordinate here, minus the y coordinate here, and you get y minus 7. And so using the Pythagorean theorem, we get x plus 5 squared plus y minus 7 squared is equal to 6 squared. And there's our equation using the Pythagorean theorem. All right, so it says, which is the equation of a circle that has a diameter with endpoints 1, 3, and negative 3, 1? So basically what we need to know, so just to kind of provide you with a quick graphic here, so these are one of my endpoints of my diameter, and this is the other endpoint. So we have the two endpoints of the diameter for my circle. So this right here is my diameter, which means that halfway between those 2 points is my center. So I need to do the midpoint between those these 2 points here in order to get my center. So let's use the midpoint formula. So to find the midpoint, you take the average of the x coordinates and the y coordinates. So we got 1 plus negative 3 divided by 2, and then the y coordinates are 1 and 3 divided by 2. And so that's going to give me my center. This is going to be negative 2 divided by 2, which is negative 1. This is going to be 4 divided by 2, which is 2. So there's my center, which is HK. Next, we need to find our radius. So we need to figure out how long that distance is. So we need to use the distance formula. So remember, to use the distance formula, it's the square root, and then you subtract the x coordinates. So it's going to be 1 minus negative 3 squared. And then you subtract the y coordinates squared. So 3 minus 1 squared. So it's going to be the square root of, this is going to turn into a plus, so it's going to be 4 squared, which is 16. It's going to be 2 squared, which is 4. So you get square root of 20 for the diameter, which means that the radius has to be square root of 20 divided by 2. So there you go. Now we know our radius and we know our center, so we can plug it into the equation of a circle. Remember that the equation of a circle is x minus h squared, and I'll write it over here, plus y minus k squared equals r squared. And so h is negative 1, so the double negative turns into a positive here. So we got positive 1 squared plus y minus k squared equals r squared. So it's going to be the square root of 20 over 2 squared. And the square root of 20 squared is 20. The square root of 2 squared is 4. 20 divided by 4 is 5. So we end up getting that the radius squared is 5. So this is the equation of my circle. X plus 1 squared, y minus 2 squared equals 5. And so the answer is C here. All right, so for number 4, what is the equation of a circle with a radius of 3 and the center of HK? So let's plug it in. That's all we got to do. It's x minus h squared plus y minus k squared equals r squared. So it's x minus 3 squared plus y squared, the 0 doesn't really do anything, equals 9. Now, that's the equation of the circle in standard form. However, they have it in a different format. So basically, they have one side equal to 0. So let's move everything to one side. Let's just subtract the 9 on both sides here. And we're going to have to FOIL this. Okay, so if I want to FOIL that, it's going to be x minus 3 times x minus 3. And then I got to FOIL it. And then I got plus y squared minus 9 equal to 0. So let's FOIL this. X times x times negative 3 times x, and then negative 3 times negative 3. Notice that the negative 9 cancel, and this becomes negative 6x. And so there's my other equation in another format, and it looks a lot like this equation, so the answer is A. All right, so number 5, determine whether 0.68 lies on the circle with a given radius and center. So that's my R, that's my HK. So the equation is x minus 3 squared plus y minus 5 squared equals radius squared, and 4 squared is 16. Then we can plug in the coordinates for x and y into this equation. So we plug in for x, plug in for y. So we got 6 minus 3. And that coordinate was originally 8, so 8 minus 5. We get 3 squared plus 3 squared is equal to 16. So 3 squared is 9. So 9 plus 9 is 18, which is not equal to 16, which means the point does not lie on the circle. So it doesn't lie on the circle. All right, so number 6, the equation represents circle A. The point B lies on the circle. What is R, the length of the radius of the circle? So we got the equation, and what we're going to do is we're going to plug in x, y into the equation to see if we can find the radius. So we got 4 minus 1 squared, 7 minus 3 squared equals r squared. We got 3 squared plus 4. And we know that that's 9 and 16. 9 plus 16 is 25. Take the square root to get the radius of 5. All right, so we're looking at this last question here, which is the equation of circle B. So we're just going to find the equation of the circle. We know that the center is this here, and it's 2, 0. So that's HK. We know that the radius is 1, 2, 3, 4 units across. And so now we got the radius. So then the equation has to be x minus h squared plus y minus k squared equals r squared. So it's x minus 2 squared plus y squared equals 16. All right, so we're done with the circle standard. So the next standard is use coordinates to prove simple geometric theorems algebraically. For example, prove that a figure defined by 4 given points in the coordinate plane is a rectangle. Prove or disprove that the point lies on the circle center of the origin containing the point 1, 2. So these are just some examples of coordinate proofs. So this is all about coordinate proofs and such, and properties. Okay, so let's tackle the first question. The first question is somewhat involved because we need to do a bunch of calculations here. We want to select to see which one is true. Now, in order to prove that these are true, you need to actually do the calculation. So let's calculate AB, CD, BC, AD, and so on. Let's calculate all of those and see what we get. And let's calculate the slopes as well, because we're going to need to know the slopes of each of these. All right, so let's calculate the distance for AB. Now, in order to do that, we need to know the rise and the run. So the rise here is the distance from the y-coordinate is B and the y-coordinate is 0. So B minus 0 is B. And here, the distance to find the horizontal, that's A minus 0, which is A. Okay, so the slope of AB is B over A. And the distance for AB is the square root of the rise squared plus the run squared. So that's my distance for AB and so on. Now, and the slope. Now let's do the slope of BC and the distance. The distance is pretty easy. The distance is just the difference between the x coordinates. So we got to subtract c minus a and a. So c minus a, which is c minus 2a. So that's the distance. The length of that line segment is c minus 2a. So now we know that BC is c minus 2a. Now let's do the slope. Now the slope is rise over run, right? But we know that the rise is 0 because it's not going up at all. And the run is this guy, c minus 2a. Now 0 divided by anything is 0. So the slope has to be 0 here. Okay, so now we're done with that. Let's look at CD. So CD is going down, so the slope is going to be negative. So let's do the rise and the run. So this is the run, this is the rise, which in this case is going to be negative. Now to get the run, you have to subtract the x coordinates here. So you got to do c minus parentheses c minus a. Now c minus c cancels, leaving you, and then this double negative turns into a positive, so that's going to be a. So this is a. And then to get the rise, then you have to subtract the y-coordinates. So b minus 0 is b. So it's going to be negative b. Okay, so the slope for CD, and I'll actually do it over here. The slope for CD is rise over run. Okay. And we know that the rise was, and then so let's do the distance. So the distance for CD is the square root of the rise, which was a, or the run, which was a, and the rise, which was negative b squared. Now we notice that negative b squared is still the same thing. A negative squared is still a positive. So I can just call this b squared and it'll be the same exact thing as negative b squared. So I'm going to leave it like that. Now let's do the distance and slope for that. So the slope for AD, so the distance here, you have to subtract the x coordinates. So it's going to be c minus 0, which is c. And so the slope is rise, which is 0, divided by run, which is c. 0 divided by c is 0. So now we got all of the slopes. Let's calculate the final distance. The final distance is c minus 0, which is c. All right, so now we got everything that we need to know. Oops, I didn't mean to erase all that, so let's keep that. Okay, so AD was C, and we can get rid of this stuff. All right, so now let's go ahead and answer the questions. So AB is equal to CD, is that true? AB is equal to CD, yes, that's true. So therefore, we will check that. AB is equal to BC, no, that's not true. AD is equal to BC plus 2A. Well, AD is C, right? And BC is C minus 2A. And then it says add 2A to it. So then the 2A is canceled because that's negative. And so C is equal to C. So yes, that's true. Is AB parallel to CD? Well, the slope of AB, remember for it to be parallel, the slopes have to be equal. The slope of AB is B over A. The slope of CD is negative B over A. They're not equal. So we are not going to check that. AD is parallel to BC. Well, AD is C. Well, let's look at the slope. Let's look at the slope. The slope of AD is 0, and the slope of BC is 0. So the slopes are the same. Therefore, we can check this, and that's it. All right, number 2, the vertices of triangle DEF are given. What type of triangle is it? All right, so if we want to figure out the triangle DEF, well, we need to figure out the distances, right? We need to figure out the length of DE, EF, and a DF. So let's calculate those distances. So if we want to figure out DE, we just got to subtract the x coordinates for D and E and subtract the y coordinates, square them, add them, and then take the square root. So the distance formula, the square root of, subtract the x coordinates, 16 minus 1 is 15. Subtract these coordinates, negative 1 minus 19 is negative 20, and then squared. And there's my DE. And we'll get that as a decimal. We'll actually get this, when you do this, you actually get 25. Now for DF, subtract the x coordinates for D and F. So negative 8 minus 1 is negative 9. Square it. Negative 8 minus 19 is negative 27. Square it. You get the square root of 810. And then finally, we got EF. So we're going to subtract the x coordinates for E and F. So negative 8 minus 16 is negative 24 squared. And then we got negative 8 minus negative 1. Remember, negative 8 minus negative 1, that turns into a plus. Negative 8 plus 1 is negative 7. And if you did that, you get 25. All right, and so we notice that these two distances are the same. And remember that if DE, if you have two of the sides are the same in a triangle, then that's referred to as an isosceles triangle. So there we go. We got an isosceles triangle here. Okay, so number 3, the vertices of GHJK are given. What is the most precise classification? So again, for these, it's better to just graph it so that you can get an idea of what it looks like. So that's negative 1, 0, that's G. H is 1, 6. We have J is 5, 6. And we have K is 5, 2. And so if you draw it, you can see that looks like a kite. And it's a quadrilateral for sure, but we want the most precise classification. It's definitely not a trapezoid because a trapezoid has two sets of parallel sides, and these are not necessarily parallel. We can prove that because the slope of this is actually 0. it doesn't rise at all, right? They're both at the level of 6, h and j, so 6 minus 6 is 0. So the slope of that is 0. The slope of this is definitely not 0 because it's sloping upward. So it's definitely not a trapezoid, and it could be a quadrilateral if we cannot classify anywhere else. It's definitely not a parallelogram because it's not even, doesn't have any parallel sides. And so is it a kite? Well, the way we define it as a kite is if these are the same and these are the same length. So let's see if that's true. So if I were to do the distance here, the distance from there to there, well, it's from 1 to 5, which is 4. 5 minus 1 is 4. And then the distance from here to here is, well, it's from 6, it's from 2 to 6, and 6 minus 2 is 4. So yes, these are congruent. And then we have to verify these. So the distance here, well, this goes, let's see the distance here and here. 1, 2, 3, 4, 5, 6 spaces here. And then we have 1, 2 spaces here. And this is 1, 2, 3, 4, 5, 6 spaces here and 2 spaces here. So yeah, it's 6, 2, 6, 2. And so they have to be the same distance, and therefore they are congruent. And so this is a kite. Okay, so number 4, if you are given the coordinates of A, B, C, and D, select all the ways that you could prove that it's a rectangle. All right, so let's take a look at all the ways that we can prove this. So we have a rectangle, A, B, C, D. A, B, C, D. And it says use the slope formula to show that AB is parallel to CD and BC is parallel to AD. And AC is perpendicular to BD. So AC is perpendicular to BD. Okay, so first off, if this is true, that AC is perpendicular to BD, then that means it's not a rectangle. That means it's possible that it's a square, and or a kite, right? So or rather a rhombus. Sorry, it's possible that it's a rhombus or a square. It's not going to prove that it's a rectangle per se. Remember that this, for a generic rectangle, the angle between the diagonals is not necessarily a right angle. So it's actually not a right angle if it's a generic rectangle, smaller than 90, or actually greater than 90 for here, but smaller than 90 here. Okay, so it's definitely not. So this is not correct. All right, so let's look at the next set of criteria. For this next part, use the distance formula to show that AB is equal to CD, BC is equal to AD, and AC is equal to AB, or AC is equal to BD. And the answer is yes, this is true. This defines it as a rectangle. A rectangle is a parallelogram, and we know it's a parallelogram because we know that we proved that the opposite sides are congruent, so that proves that it's a parallelogram. And so a rectangle is a parallelogram with congruent diagonals. And so we established that yes, it's a parallelogram, it does have congruent diagonals, and therefore it's a rectangle. So that is a more direct way to prove it's a rectangle. Okay, so now use the distance formula to show that AB is equal to CD, BC is equal to AD, and use the midpoint formula to show that the midpoint of AC and the midpoint of BD are the same point. So basically showing that the midpoint is the same point. Well, the problem is, this is true for a rectangle, by the way, but it's also true for any parallelogram. This is true for a kite, right? Or not a kite, a rhombus, right? This is true for a rhombus, a parallelogram, a square, a rectangle. So that's not going to really help us out, okay? So that's not really going to show that it's a rectangle. This only shows that it's a parallelogram, okay? So if I give you a parallelogram, they also meet at the same point in the middle, right? So that's not really helping. Okay, so it's definitely not the third option. So cross that out. Use the distance formula to show that AB is equal to CD. And use the slope formula to show that AB is parallel to CD. Okay, so those are parallel. And AB is perpendicular to BC. AB is perpendicular to BC. Okay, so looking at the first part, the fact that these are congruent and that it's parallel, that alone, so just getting rid of the right angle, that alone proves that it's a parallelogram. Okay, So a parallelogram can be proved by showing that the two opposite sides are congruent and they're parallel. Now, the fact that it's a right angle here actually shows that because it's a parallelogram and it has one right angle, that automatically classifies as a rectangle. And that's because if you have one rectangle or one right angle, then that must mean that these other angles must be right angles, because we established that they're parallel here. And therefore, if they're parallel, then, and these are congruent, then that must mean that it's a parallelogram. And remember that the property of parallelograms states that opposite angles are congruent. And so that's 90, then this is also 90. It also shows that the adjacent angles must add up to 180 for a parallelogram, and therefore this must be 90. So therefore, yes, this shows that it's a rectangle. Okay, so I'm going to go ahead and redraw the rectangle because of all that from earlier. Use a slope formula to show that AB is parallel to CD, and use a distance formula to show that AB is equal to CD and AC is equal to BD. So AC is equal to BD. And the answer is yes. Diagonals are congruent in a rectangle, and we've showed that it's a parallelogram. So a rectangle is a parallelogram with congruent diagonals, which in this case it is. All right. So let's look at the last question. Given the coordinates for this standard here, we have some coordinates. Which coordinates for D make ABCD a square? So it's just easier to draw it out. Once you draw it out, it's actually pretty obvious where the coordinates are going to be. So I highly suggest making a quick drawing, nothing too crazy. So that's A, that's B, and then C is going to be 9. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 4. And then, so we want to figure out what D is, okay? So if we want to figure out what D is, well, D is going to be maybe somewhere out there somewhere, right? So that we can make this a square. Now, what makes it a square? Well, the thing that makes it a square is that this line for CD has to make a right angle with this for sure, and they have to be the same length, right? Obviously, they have to be the same length for it to be a square. Okay, so we need this to be a right angle. So that means that BC has to be perpendicular to this line. So we need to figure out the slope of BC. So let's do that now. We need rise over run. The run for BC is the distance from 4 to B. B is at 2. So the slope, so the rise is 2. 4 minus 2 is 2. And then the run is the distance from 5 to 9, which is 4. So the slope of BC is rise over run, which is a half. And so remember that to find the perpendicular slope, I need to flip the fraction and then change the sign. I need to do the negative reciprocal. So I need to do the negative reciprocal of BC. And that's how I get the perpendicular slope. Okay, so I need to flip that. That becomes 2 over 1, and then change the sign to opposite, so negative. So the slope is negative 2 over 1. That means I'm going to go down 2 for every 1 space to the right. Or I go 1 up, 2 left. And that's exactly what I want to do. I want to go 1 up and 2 up and 1 left, okay? Because that's the rise is a 2. So I'm going to go 2 up and 1 left. And if I did that, well, I know the coordinate for C is 4, so that means if I go 2 up, then I'm at 6, right? So I'm at a coordinate of 6. Let's see where the A coordinate is. Actually, the A coordinate should be at 3. I don't know why I put A so... Oh no, the A coordinate is 6, sorry. Yeah, so the A coordinate was at 6. So it's 3, 6. The C coordinate was at 4. Okay. Okay, so let's go ahead. What I'm going to do is I'm going to actually leave it as 2 over 4. I'm not going to do anything to it. I'm just going to leave it as 2 over 4. And then when I flip this, I'm going to leave it as 4 over 2 and then negative. The reason why I want to do that is because I want to make sure that the distances are the same, and this ensures that that's the case. So instead of going up 2, I'm going to go up 4 and then over 2, okay? So I'm going to go up 4 and then over 2, and that ensures that the distances are the same, right? And so now if I go up 4, then D is now going to be at 1, 2, 3, 4. It's going to be at 8. So the y coordinate is 8, and the x coordinate is going to go over 2 to the left. So that means the x coordinate is going to go from 9 to 7. So there you go. So the x coordinate is 7. There you go. So that makes it a square. So now the distances here are the same and they're perpendicular. And so now we got ourselves a nice little square. So there you go. The coordinates for D are 7, 8. Now there's multiple ways that you can solve this problem. This is just one way that I just thought of as I was doing it. Okay, so for the next standard, we're looking at prove the slope criteria for parallel and perpendicular lines. So this is all about lines, parallel, perpendicular, all that. So let's go ahead and continue with number 1 here for the standard. What is the equation that is perpendicular to 3x plus y equals 2? Okay. Give me a sec here. Okay, so it says, what is the equation of a line that is perpendicular to 3x plus y equals 2 and passes through the point 6, 8? Okay, so we do have the coordinates, so let's use that real quick. Sorry about that, it's glitching up a little bit. Screen is going blank back and forth. Okay, so let's go ahead and continue here. So we got the equation. So let's go and write down the equation. 3x plus y equals 2. And the coordinates are 6, 8. So this is going to be x. This is going to be y. So remember that we need to convert this to slope-intercept form. Slope-intercept form is y equals mx plus b. So we're going to get rid of the 3x. And we get negative 3x plus 2. Now it's in slope-intercept form. And so we can identify that the slope is negative 3. Now, in order to get that to be perpendicular, remember what I said earlier is I have to flip the fraction and then change the sign. So I got to flip that. There's an invisible 1 there. So it becomes 1 over 3. Change the sign from negative to positive. And so now my slope is 1/3. So now if I use y equals mx plus b, I'm going to use 1/3 there. And there's my equation. And that's not really going to help because we need to know whether b is 2 or 6. So we're going to plug in x and y into here to solve for x. So 8 is equal to 1/3 times 6 plus b. Now 6 divided by 3 is 2. So we got 8 equals 2 plus b, which means b is 6 because 6 plus 2 is 8. And then you can replace this with 6 and you got your equation. For number 2, which equation represents a line parallel? Parallel means the slopes are the same. The slope of this is 2. So that means the equation is y equals 2x plus b. And there's my equation. And we can easily pick off the equation. It's definitely not going to be this one because that's negative 2. For b, let's see if that matches up. Notice that they moved the y over and the x over to the left side. So let's subtract this x and move it to the left side. So we get negative 2x plus y equals something. B could be any number. And so that looks like this one. Negative 2x plus y equals some number. So the answer is C. All right. So for number 3, select all the equations. Okay, so it says select all the equations that represent a line that is perpendicular to the line with the equation y equals 2x minus 8. So it has to be perpendicular. So the slope here is 2, which means if we flip it and then change the sign, the perpendicular slope is negative 1/2. So this looks to be negative 1/2, so that's good. We'll need to see if these become negative 1/2 if we put it in slope-intercept form. So let's look at this equation, solve for y. So get rid of that x there, move it out, and then divide by 2. And yes, that becomes an invisible negative 1/2. So yes, that becomes negative 1/2 for the slope. Let's look at this next equation, negative x plus 2y. If I move that over, then that becomes plus x But then if I divide by 2, that becomes a half, not negative 1/2, right? So that cannot be it. And then we'll do the last one. So if we add the x, that makes it positive. So far that's not good. However, if we divide by -2, that turns it back into negative, right? And so that's a good thing. It becomes negative 1/2. So yes, that's correct. So those are the 3 correct equations. All right, so for number 4, what equation must be true to prove that Q is perpendicular to N? Remember, for 2 slopes to be perpendicular, right, then you have to do the negative reciprocal of the other slope. So you flip the slope and then you change the sign to its opposite. However, if I move this m over to the other side by multiplying it, I get that if I multiply the 2 slopes, I get -1. So there's 2 ways to do it. The product of the slopes is -1, or the slopes are negative reciprocals, okay? So slope of Q must be the reciprocal of the slope, not the reciprocal, the negative reciprocal. So that's not true. The slope of Q must be the negative reciprocal of the slope of N, yes. Slope of Q must be the slope of N multiplied by -1. No, it's not multiplied by -1. This slope is equal to -1 when you multiply the 2 slopes, rather. And so yeah, so the answer is definitely going to be B. All right, so number 5, which statement is true about the 2 lines whose equations are given below? So we want to see if they're perpendicular or whatnot. So let's convert them to slope-intercept form. Remember that we need to solve for y. So we're going to subtract 3x on both sides to get rid of it. Then we'll divide by -5, everything by -5. If I do that, I get y by itself, which is what I wanted. These 2 negatives become a positive. And these 2 negatives become a positive. Okay, so now I have my equation for this first one. So this is going to be equation 1. So let's do equation 2. So equation 2, I get y by itself by adding this because it's negative. And so I get 2x minus 8. That's going to be equation 2. So notice that the slope of 2 is, equation 2 is 2. The slope of equation 1 is 3/5. They're not reciprocals or negative reciprocals of each other, and they're not equal to each other. That means they cannot be parallel and they cannot be perpendicular, so they're going to be neither. So the answer is they intersect, but they're not perpendicular. Okay, so the next standard, find a point on a directed line segment between the 2 given points that partitions the segment in a given ratio. All right, this is probably the harder of the standards, probably one of the hardest standards that students tend to struggle with. Okay, so we'll go ahead and get through these questions as efficiently as possible while still going over some details. So the coordinates of the point on the directed line segment from K to L partitions the segment in a ratio of 3:2. So we got a 3:2 ratio. Remember what that means is that you have a total of 5 parts, right? So you have a segment that you're breaking up into 5 pieces, just like this, 1, 2, 3, 4, 5 pieces. But you want it to be in a 3:2 ratio. So you want to put a point here that is 3 away from one and 2 away from the other. That's what 3:2 ratio means here. Okay. So now that we talked about that, there's 5 parts, which means that we're going to divide by 5 whenever we do, these calculations. Okay, so let's go ahead. So that means the fraction here is you take this number and divide it by 5 parts. So the fraction is 3/5. Okay, so that's what you need to know as far as the fraction is concerned. So for K to L, what you're going to do, let's go ahead and draw it out. That's K, and that's L. So we got a line segment, and basically we want to split it into 5 pieces. Now what we do here is we find the x distance and the y distance, okay? So the distance in the x direction, which is from -5 to 5 is 10. The distance in the y direction from -4 to 1, well, it's 5, right? The distance between those two, if you count the number of hops, 1, 2, 3, 4, 5, right? So there you go. And then you have to multiply these by the fraction, right? Because you want to split them into the 3:2 ratio, which means it's 3/5 of the way. Okay, so you're doing it, so you're going to multiply by 3/5. So basically the fraction 90% of the time is going to be this number divided by the total number of parts. All right, so we got 5 divided by 5 is 1, 1 times 3 is 3. 10 divided by 5 is 2, 2 times 3 is 6. Okay, so you're going to go 6 in the x direction, 3 in the y direction. You're going to go 6 from k and then 2 from y. So 1, 2, 3, 4, 5, 6, and then 3 in the y. 1, 2, 3. So you're over here. And the coordinate for that is 1, -1. And there you go. And that's how you get the partition it in that ratio. Okay, so let's do another practice. It says it's 1/3 of the way from A to B. So now they give us the fraction. So let's find the distance in the x direction and the y direction. So the distance in the x direction here, 1, 2, 3, 4, 5, 6, 7, 8. And we're going to multiply that by the fraction of 1/3, right? Oh, wait, that's not by 8. Sorry. I want to make sure that I get that correctly. Because this is right here, this is at -5. So this is 1. This is going by... Here, let me get rid of all of this this line because it's hard to see the number line. This is going by 2s, so you got to be careful. 2, 4, 6, 8, 10. Okay, so be careful with the scale. Now this here is at -5, so it's going to be 1, 2, 3. Each of these is worth 2. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Or you could just subtract 12 minus... it's going to be here. This is -3. Sorry, I said it was -5. It's -3. Sorry. So you could do 12 minus -3, which is 15. Okay, that's one way to do it. And the distance from there to there is 4 minus -2, which is 6. So now we got the two distances. Let me get rid of all this mess here. So now we got 15 and 6. Then we got to multiply them by the fraction 1/3. 6 divided by 3 is 2. Multiply that by 1/3. 15 divided by 3 is 5. So that means you're going to go 5 spaces to the right, 2 spaces up from A, because it says you want to go from A to B. So from A, you're going to go I got to be careful because remember, each of these is worth 2. So it's 1, 2, 3, 4, 5. And then I'm going to go 2 spaces up, which is really one of these. So I'm over here. So the coordinate is 2, 0. All right, so there's my coordinates. All right, so point A has coordinates -5, 3. If point 16 is 3/4 of the way from A to B, what are the coordinates of point B? This one's a harder directed line segment problem. This is actually one of the hardest ones of these types of problems to do, but I'll show you how to do it. So here, let's go ahead and draw this scenario out. Picture's worth 1,000 words here. So this is the point that partitions the line segment. We want to figure out where B is, okay? So we don't know where B is. It says this is 3/4 of the way, so that means that's most of the line segment. So B is probably like maybe over here or something like that, because this is 3/4 of the line segment and this is going to be a quarter, right? So you can kind of guesstimate what B could be from that information, right? So this is 3/4 of the distance. So we got to figure out what B is, but we do know that this is 1/6. This is -5, 3. So if this is 3/4 of the distance, well then let's find the distance horizontally here in the x and the y. Now the distance from here, well this is from 1 to -5, that's a distance of 6. And then in the distance in the y, it's from 3 to 6, which is 3. So the distance here is 3, distance here is 6. Now, we know that this 6 is only 3/4 of the line segment, right? Because this is 3/4. So we know that 6 is 3/4 of what the actual distance would be. Let's call the actual distance ABX, okay? In the x direction. And we know that 3 is only 3/4 of the distance that it would normally be, right? of ABY. And so that's the equation that I want to set up, and I can solve, and that will give me my coordinates of my B. That'll help me with the coordinates. Okay, so let's go ahead and solve that equation. We'll multiply by the reciprocal, which is 4/3. So 6 divided by 3 is 2. 2 times 4 is 8. So we got that ABX is 8. Let me actually write that over here. And let's do the same thing here. Multiply by 4/3 to cancel that out. 3 divided by 3 is 1. 1 times 4 is 4. So ABY is 4. And so what that means is that you're going to go 8 spaces to the right, 4 spaces up from A. Okay, so from A, you're going to go 4 spaces. Let's see here. So you're going to go 8 spaces to the right. So let's do that. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So that's a coordinate of 3 there, x coordinate of 3. And then you're going to go 4 spaces up. 1, 2, 3, 4. That's actually a pretty good approximation there that I did with B. And so there you go. So B is going to be 3, 4. Okay, so that's a tougher type of problem because of this equation setup with the 3/4 and all that. All right, so number 4, what are the coordinates of the point 4/5 of the way from D to E? That says D to E, it should say A to B, which is a typo. So you're going to go ahead and fix that if you have the handout. So let's do the same thing we did earlier. Let's do the x distance. The distance from 6 to -4 is 10. And so that's 10, and this is going to be another 10. Then you multiply by 4/5. And 10 divided by 5 is 2. 2 times 4 is 8. So both of these are going to be 8. So you're going to go 8 spaces. Well, that's the distance there. And then so you're going to go 8 spaces to the right and 8 spaces to the right. From A, you're going to go from A. Sorry, I circled D. So it's going to be... Remember, each of these is going by 2s. So this is 2, 4, 6, 8. 2, 4, 6, 8. And there's your coordinate. So your coordinate is 4, 4. Okay, so number 5, a city map is placed on a coordinate grid. The post office is located at 535. So 5, 35. Let's graph that. 5, 10, 15, 20, 25, 30, 35. Let's go by 5s here. So the post office is here at 535. The library is located at 1510. So it's 15 and then 10. That's the library. And the fire station is located at 9 and then 25. So 9 is just before 10. This is 10 here. So just before that. And that's the fire station. So there's my directed line segment there. What is the ratio of the length of PF to LF? So from PF to LF. So what is the ratio of that distance? Well, in order to find that, we need to figure out the x distance, okay? So let's do, well, we could do the x distance or the y distance. Let's do the y distance. Let's do the x distance. I prefer doing the x distance here. The coordinates of here is 925. So let's focus on just the x distances. So it's between 5 and 9. So that distance is 9 minus 5 is 4. And the x distance for the green is from, well, the coordinates for L was 15, 10. So the x distance is from, well, it's from 9 to 15, which is 6, right? 15 minus 9 is 6. So there you go. So let's do the ratio of these x components. So the ratio of 6 to 4. So 6 to 4 ratio. And then let's reduce it, right? Let's reduce it. So we can divide both of these by 2. And so the ratio is a 3 to 2 ratio. And they said they want the ratio of PF to LF. So PF must go first. So actually, this 4 in purple must go first. And so it's going to be a 2 to 3 ratio here. And there's my answer, which is A. All right, so let's go to the next standard. Use coordinates to compute perimeters of polygons and areas of triangles and rectangles using the distance formula. All right, this problem is actually way more involved. Some of these problems can be pretty involved because you're trying to find distance formula and all of that. So remember that the area of a triangle is 1/2 base times height. So we want to figure out the area of this triangle, and so we're going to need the base and the height. So let's call this base. Let's call this height. So so the base is going to be AC. So let's find the distance for AC. Well, we know that the x component here is from 2 to 6, which is 4. And the y component is from 1 to 3, which is 3 minus 1 is 2. So we can do the distance formula to get b, which is the square root of the rise squared plus the run squared. And when you do that, you get 4 plus 16 is 20. So you get square root of 20. And square root of 20 is the same thing as 2 times the square root of 5. And again, the way I do that is square root of 4 times square root of 5 is 20. And then square root of 4 is 2. All right, so let's go ahead and do h. So h, the x component is 2. It's going from 4 to 6. And the y component goes from 7 to 3, which is 4. So it looks like it's the same thing. H is actually the same thing as AC. 2 squared plus 4 squared. So it's going to be 2 squared of 5. So they're both the same. So then we can plug it in. So the area is 1/2 times 2 square root of 5 times another 2 square root of 5. Now half of 2 is 1. And then so square root of 5 times square root of 5 is 5. So you get 2 times 5, which is 10. All right, so number 2, this one is actually quite interesting. And in the sense that it's very involved. Actually, this might not be, I might be thinking of a different problem. This one is actually not too bad at all. So it says 2 of the vertices of a triangle are 0, 1 and 4, 1. So that's one of the sides of the triangle. What are the coordinates of the third vertex have to be to make a triangle with an area equaling the area of the triangle is 16? All right. So the area of a triangle is 1/2 base times height, and the area is 16. And so we know that the base of this is this guy, and it's a distance of 1, 2, 3, 4. So we can replace b with 4 and then find h. So half of 4 is 2, and so h has to be 8, because 2 times 8 is 16. So the height has to be 8 units. So the height could be 8 units up, or it could be 8 units down, right? So if this is a y coordinate of 1, then if it's going 8 units up, then it'll be at 9, 4. If it's 8 units down, well, then it's going to be 8 minus 1, or 1 minus 8 is -7. So it could be at -7, 4. So it could be at either one of those points. Or it could be, anywhere on this line here. It could be at, it could be, sorry, I said 9, 4. It's 4, 9. That's what I meant to say. And then this is going to be 4, -7. Or it could be at 2, -7, or 2, 9, or 2, -7, right? It could be at any point as long as the y coordinate is -7 or 9. So it looks like -7. They chose to be 4, -7. So it's going to be C. All right. So number 3, the endpoints of one side of a regular pentagon are given. What is the perimeter? All right, so they gave us one side of the pentagon. Which is this. So they give us that side of the pentagon. So we got to find the distance of that side. And then we multiply it by 5 sides because that's a 5-sided shape, and that will give us my perimeter, right? I just had to add 5 of these, and that will give me my perimeter. So the perimeter is 5 times that distance. So let's find the distance. We need to use the distance formula. So take the square root, subtract the x's, 2 minus -1, square it, plus, then subtract the y's, 3 minus 4 squared. So you get square root, 2 plus 1 is 3, so you get 3 squared, which is 9, 1 squared, which is 1, so you get the square root of 10. So the perimeter is 5 times the square root of 10. All right, number 4, a triangle is shown on the coordinate plane below. What is the area of the triangle? All right, this one is pretty involved, okay? So I don't really like this question too much because there's just so much stuff going on here. It's a very simple equation, 1/2 base times height. However, you got to find the height in the base, right? So you have to figure out, well, remember that the height has to be at a perpendicular, right? For it to count as the area. So if I were to make this as my base, well, then my height would have to be perpendicular to that. And so not only do I have to figure out how long this is, and I have to figure out how long B is. And finding out how long H is pretty a monumental task as it is. So let's go ahead and find B. That's easy. That's easier. So to find B, you're going to find the rise and the run. So the rise is from -5 to 4, which is 9. And the run is from -4 to 4, which is 8. Okay, so then the distance is square root of 8 squared plus 9 squared for B. So B can be found pretty readily. Square root of 8 squared plus 9 squared, which is a square root of 145. I'm gonna start doing all of these as a decimal, because if I do not do it as a decimal, it's gonna be very calculation intensive, and we don't really want that for a problem that's already complicated as it is. So you get 12.04, so it's approximately 12. Okay, I'm gonna just round it. Okay, so this is approximately 12. So now let's go ahead and find the H. Now to find the H, we need to do the slope. This is -9, by the way, because it's going down, right? So it's downward slope. So in order to figure out where H is, I need to figure out where this meets up to make that a right angle. In order to make that a right angle, I need to know the slope of B, right? The line that we found the distance for B, and that the slope is -9/8. So the slope of this line is equal to -9/8. We just found it. So I need to make it perpendicular. So I need the perpendicular slope, and that will give me this guy, okay? So let's do that in purple. The perpendicular slope is the negative reciprocal of that, so I gotta flip that and then change the sign to positive. All right, and then I need to find the equation of both of these lines, the red line and the purple line. So a bit of a pain in the butt here. So let's go ahead and do the equation of the red line first, okay? So let's call that red line YB, the equation. Remember, the equation is y equals mx plus b, right? So it's going to be -9/8x plus b. Now this b has nothing to do with this b. It's just coincidence, okay, that we have that b being the same. That's a different b. That's the b for the y-intercept. All right, so we're going to pick one of these coordinates. Let's choose this coordinate to plug in for x and y. So y is 4 and x is -4. And that'll help us find b. Again, I'm going to stick to decimals here. That'll make this simpler. Okay, so I know that 9/8 is equal to 1.125. So I'm going to change this to -1.125 x. And so we got 1.125, negative 1.125 times -4 is equal to 4.5. So this is equal to 4.5, which means that b has to be -0.5. Okay? So now we know what b is. So that's my equation. Let's change this to -0.5. So that's the equation of the red line. Let's do the equation of the purple line. Equation of the purple line is, let's call the purple line YH for height. So it's mx plus b. What is 8 divided by 9? Let's do that right now. Well, 8 divided by 9 should be 0.888. So it should be about 0.89. So 0.89x plus b. Let's go ahead and find b. Let's pick a point on this line. This point is on that line, -4, -2. So y is -2 and x is -4. If I do that math, I'm just going to do that math real quick. Let's do it over here. 0.89 times -4 is -3.56. If I add that to -2, which is the same thing as basically subtracting 2, so it's basically -2 minus that, I get -5.56. And so I'm going to change this to -5.56. It'll make life easier, believe me, having it as a decimal. Okay, so now that we know the equations, we can set them equal to each other. So YB is equal to YH. So set these two equations equal and solve for X to figure out where they intersect. So -1.25x minus 0.5 is equal to 0.89x minus 5.56. All right, so again, a lot of decimals to work with. I'm going to subtract this on both sides. And then I'm going to add this to both sides. So we got a lot going on. So this cancels, this cancels. This plus 0.5 is -5.06. This minus that, we had to add those. So it's going to be 4, carry the 1. 3, 1, carry the 1. Actually did this incorrectly. This is 0.890. So 5 plus 0 is 5. This is going to be 11, carry the 1, and then that's going to be 8, 9, 10, carry the 1. So it's going to be -2.015. I'm actually going to double check that. I should have just typed it in to begin with. I just want to make sure that the math is correct. Okay, there you go. And then we'll divide by this on both sides to finally get where that intersection point is. I know it's a bit of a pain. And so we get it's about 2.5. So approximately 2.5. Okay, so that's approximately where it is at the 2.5 point. All right, hold on a second. I think there might be an issue with the B coordinate here. So let me double check that real quick. So we said it was -0.89 times -4, which is -3.56. And so I subtracted it here. I had to add it. I subtracted it. So let's go ahead and add it, and then we'll get the correct answer. Okay, so it's 1.56. Sorry about that. It's not 5.56. It's 1.56. So this is actually positive 1.56. So that means we're going to change this to positive 1.56. That's the only thing that changes here. And so that means we'll be subtracting 1.5, or we'll be adding 0.5 to that. And so this is going to change. This is going to change to 2.06. Okay. Yeah, so sorry about that. Let's go ahead and I don't think anything else changes. Let's double check here. Yeah, I think that's fine. So let's go ahead and do 2.06 divided by 2.015. So that's about -1. So this is actually going to be about -1. Okay, that's better. I found out that there was something wrong because this should be at around -1, which now it is. Okay, so now we know that that's approximately -1. Could we have estimated that? Probably. We could have probably guesstimated that that's about -1, but I wanted to make sure that that was the case. Okay, so now we know where that is. The coordinates for that are -1, 0. Well, actually, it's not. We don't even know what if it's 0 or not. So let's figure out what the y coordinate for that is. So we know the x coordinate is about -1. Let's plug it in to get y. So let's plug this in here to get y. So yh equals 0.89 times approximately -1 plus 1.56. So let's see what that is. So you get -0.89 plus 1.56. That's about 0.67. Okay. This is approximate, of course. So it's about -1 and 0.67. Let me make sure I emphasize that, because that's important. Now, in order to find the length of h, I need to do the distance formula between this and that. So a lot of work, but we can do it quickly. Let's do that. The distance formula between those, and that'll give me the h finally. So h is equal to the square root, subtract the x coordinates, -1 minus -4 squared plus 0.67 minus -2 squared. And then we'll do this on the calculator. I'm going to do this over here. So we get the square root. And this is going to be -1 plus 4 is just 3, so it's going to be 9. I'm just doing some mental math here. And then for the decimal part, that's going to be 0.6 plus 2, so it's going to be 2.67 squared. Okay, so 2.6, sorry, I got to change that and square it. And we get about 4. Okay, so approximately 4. Finally, we got about 4. So now we can plug it in and finally get our area. Sorry for that. It's a lot of work for this problem, unfortunately. We have 1/2 times the base is 12 and the height is 4. And then half of 12 is 6. 6 times 4 is 24. Goodness, that was a big problem. That was about 24 square units. Simple concept, but a lot, the simple formula, but a lot to get b and h, right? And there's multiple ways of doing this problem. You can get this as the base and then do the height, which is perpendicular to that. You know, there's just so many, you know, different ways to do this problem, but this is just very complicated. There's a lot to it. All right, next standard, use geometric shapes, their measures, and their properties to describe objects. All right, so what is the volume of the CD case shown below? That's pretty straightforward. You just got to do the volume. The volume of a prism is length times width times height. So we got 8 times 1 times 8. Very simple compared to the previous problem. And it's going to be millimeters cubed. Okay, so for number 2, calculate the area of a triangle BAT with altitude AM given those, given those measurements or those coordinates. So they give you the altitude as AM, so that's h. Automatically we know that's h, the height. And so we need to figure out the distance for AM, which is the square root. Take the difference between the x coordinates, -3 minus 3 is -6, square it. And then the y coordinates, 3 minus -3 is 6, so it's going to be 6 squared. If you did this on the calculator, you get 6 squared root of 2. So I'm just going to leave it at that. That's h is 6 squared root of 2. And then to get the base, well, it helps to draw this out. So I'm going to draw it out because I don't know where the base is. So, so if I do A is at 3, -3. This is just as a visual, nothing else. And that's B. And then T is 1, 7. There's my triangle. And they said that AM was the altitude, so M has to be somewhere here. Okay, so then my base has to be BT. That's my base. So that means I need to find BT. So the B is equal to BT, which is the square root. Now we got to focus on B and T. Subtract those coordinates. 1 minus -5 is 6. 7 minus 1 is 6. Oh, so they look to be the same exact distance. So it's going to be 6 square root of 2. Plug it into the area formula. 1/2 times base times height. And 1/2 of 6 is 3. 2 times square root of 2 times square root of 2 is 2. 3 times 6 is 18. 18 times 2 is 36. We got 36 square units. All right, so let's see here. All right, so we got a couple of pages after this, so we're gonna try to get through this as quickly as we can. Dylan is building a wooden cabin. The cabin is 30 meters wide. He obtained a bunch of wood. Okay, so we want to figure out what angle so what angle should this be for the beams to meet in the middle? Okay, so this is a trigonometry problem. All right, if this is 30, then this is 15. And so we got a right triangle with 15 and 17 as a hypotenuse. We want to figure out angle theta. Well, this is adjacent and this is hypotenuse, so that's going to be a cosine. Cosine of theta is, remember, SOHCAHTOA, A over H. And then if I want to get the angle, I do the cosine inverse on both sides. And if I did that on the calculator, I would get about 28.27 degrees. All right, that's it for that one. Number 4, Abraham works at this factory and they do packages that so they package cakes in containers that look like this. So he wants to wrap the cake up. So he wants to wrap this in plastic wrap. What is the total exterior surface area? Okay, so we want the surface area. Okay, so the surface area of a hemisphere is, well, it's 2 pi r squared. And the surface area and we got to add that to the surface area of a cylinder. The surface area of the cylinder, well, we have this part that wraps around the outside, and that's 2 pi r. And then the part that wraps on the bottom, well, that's the area of a circle, which is pi r squared. So that's my exterior surface area. So we got 2 pi. We know that the radius is 5 because it's half of the diameter, which is 10. So we got 2 pi times 5 squared plus 2 pi. Oh, this should be an h here. It's 2 pi r times h. Sorry about that. So it's 2 pi times 5 times h, which is 4. And then plus pi times 5 squared. And then we calculate that. When we do that, we get 115 pi. All right, next standard. This is the second to last page. An average classroom measures 20 by 30 by 10. The maximum capacity is 45 students. What is the density? This is the density standard. So density is density is what you want over volume. And so what you want is the number of students, right? So we'll call that N. All right, so there's 45 students over, and then the volume is 20 by 30 by 10. We're assuming that it's a rectangular prism-like classroom. So then we do this on the calculator and we get 0.0075 students per feet cubed because the volume is in feet. All right, number 2, Amy bought a candle with this unusual shape. This is a triangular prism. The base, okay, so they give us the dimensions. If the height is 10, what is the volume? So we just got to find the volume of the candle. So the volume of a prism is BH. And the capital B is the area of the triangle, which is 1/2 base times height. And the base is 9, and the height is 6. So we got 1/2 times 9 times 6, and then times the height of 10. And then if you did that, you're going to get a volume of, it should be, give it a second here. So yeah, this is going to be a height of, or volume of 270 centimeters cubed, and that's it. Number 3, County X has a population density. If you ever want me to slow down, just kind of pause the video. I just want to get through this quickly here. We have a population density of 250, so the density is 250. So in this case, the density is the number of people, the population, divided by the area. That's the formula for the density here, because we're talking about square miles of land. So the total population is 150,000, so that's the number of people, divided by the land area, the geographical area. Which geometrical model could model the shape of County X? Actually, there's a typo here. This should say 200, not 250. So make that correction. Okay, so it's 200 equals that. So we're going to swap this and that to solve. And we get 150,000 divided by 200, which is going to be 750 square miles. Okay, so now we got the square mileage. Let's go ahead and find the area to see which one matches up. The area of a parallelogram is base times height, so it's 25 times 25 is 625. So that can't be it because it has to be 750. Area of a rectangle is base times height, and if I multiply that, I get 675, so no. A right triangle with a leg that is 30 miles and hypotenuse that's 50 miles. The area of a triangle is 1/2 times base times height. Let's see here. Hold on a second here. Okay, I'm sorry. It was actually 250, not 200. I looked at it wrong on the paper that I had. So yeah, it is actually 250. It's not 200. So if it's 250, then we'll change this to a 250. Sorry about that. And so this is going to be divided by 250, and so it's going to be 600 square miles. Okay. Now, so in either case, these are still not going to be match up, so it's still not going to be A or B. For part C, they give us the leg, which is 30, and they give us the hypotenuse. So let's draw that out. They give us the leg is 30, and the hypotenuse is 50. So we need to figure out the h. So we need to do the Pythagorean theorem. So it's h squared plus 30 squared equals 50 squared. And so if I solve for h, I got to subtract the 30 squared and then do the square root. And if I do that, I get h is 40. So now we know that the height is 40, and we can plug it in. So it's 1/2 base times height, and if we did that, we get 600 square miles. And so the answer is C. Okay, so for number 4, given the size and mass of each of the solids, how many times is the density of the cube x greater than the density of cube y? So let's figure out the density of cube x. The density of x is the mass, so the formula for density is mass divided by volume. So it's going to be 4 grams divided by the volume of the cube is 1 times 1 times 1, which is just 1. So the density is 4. Now the density for y is mass divided by the volume, which is 2 by 2 by 2, which is 8 centimeters cubed, which is 1/4, or 0.25. So then if I want to figure out how much times greater, I just got to do this density divided by the y density, which is 4 divided by 0.25, which is 16. So it's 16 times greater in density. Okay, so then finally, we're looking at the last problem. I know we're trying to get through this as quickly as we can. This is a very long video. So apply geometric methods to solve design problems. So there's 4 more problems here. So you got a package shaped like a prism needs to be mailed. For this package to be mailed, the sum of the length of the longest side and the girth, which is the perimeter around its other 2 side dimensions, must be less than or equal to 108. So figure 1 shows you how to do that. So let's figure out, let's measure out, it says, what is the sum of the length and the girth of the package for figure 2? All right, so that's pretty straightforward. So we need to figure out the girth, which is the perimeter around those 2 dimensions. The longest dimension is 42, so we're going to do that. So the sum is the 42 inches plus the girth. The girth is this perimeter, which is, this is 11, because that's 11 down here, so that's 11. This is 19, so this is 19, and this is 19. So it's going to be 42 plus 19 plus 19 plus 11 plus 11. That's all you got to do. And if you did that, you get 102 inches. So it looks like the package can be mailed because it's less than or equal to 108. It could be mailed at the standard rate. Number 2, you have a right circular cylinder and a right circular cone. Which is closest to the surface area? Okay, so first off, this number here should say 452, and this number here should say 1696, okay? So a little typo there. So let's go ahead and find the surface area. The surface area of a cone is, or the surface area of the part that goes around the cone is pi r L. The surface area of the part that goes around the cylinder is pi r h, or 2 pi r h. And the surface area of the bottom part of this shape is the area of a circle, which is pi r squared. Okay, so there we go. So we got pi, the radius is 12. The length is 13. We plug this in here. The radius is 12. The height is the height of the cylinder is actually 10. We got pi times the radius is 12 squared, and we add those together. And we add those together, we get approximately 1,696 feet squared, which is going to be D, which is the correction that I made there. All right, so number 3, a farmer wants to build a new grain silo. The shape of the silo is to be a cylinder with a hemisphere on top. Now it says the hemisphere, the radius of the hemisphere is to be the same as the radius of the base of the cylinder. Okay. The farmer would like the height of the cylinder to be 3 times the diameter. So the height is 3 times the diameter, which means, and remember that the diameter is 2 times the radius. So it's basically 6 times the radius. What should the radius of the silo be if the silo is to hold that much cubic feet of grain? So that's the volume. So remember that the formula for the volume of the silo is the formula for the volume of a hemisphere, which is 2/3 pi r cubed, and the formula for the volume of a cylinder, which is pi r squared h. Okay, so let's go ahead and plug in what we know. The h is 6r, so we can plug that in there. So we got 2/3 pi r cubed plus pi r squared times 6r. So this is 2/3 pi r cubed plus 6 times pi, so 6 pi r cubed. Now I'm going to go through this a little quickly. If I combine 6 over 1 with 2 over 3 with a common denominator, I'm going to get 20 over 3. So I get 20 pi over 3 times r cubed. I'm going to skip that step just so that we can save some time. And so this is the formula for the volume. Now we know that the volume is equal to this, so we're going to plug that in now. So 22,500 pi is equal to the volume formula that we got. So we need to multiply both sides by the reciprocal. And once we do that, the pi's cancel. And bottom line, if I did 3 times this divided by 20, I'm going to get 30,375 is equal to r cubed. Then I need to take the cube root of both sides, and the cube root of that number is 15. So my radius is 15. All right, number 4, Lewis is going to form a clay model of a skyscraper. The model will be in the shape of a 2-foot tall prism with a 6 by 6 inch space. You gotta be careful with this. This is in feet and this is in inches. So this is actually, 6 inches is half of a foot. So this is actually 0.5 feet. They're trying to trick you there. The clay he uses comes in containers described below. What is the least number of containers he'll need to complete the model? Okay, so let's find the volume of this container. The volume of the cylinder is pi r squared h. The radius is, it says that the diameter is 1 feet, which means that the radius is 0.5 feet. So it's pi times 0.5 squared times the height, it says is 1/2 feet tall, so it's 0.5 feet. So there's the volume of that. And then the volume of that cylinder is 0.393. Okay, so the volume of the skyscraper is, remember that this is 0.5, they're trying to trick you there, is 0.5 times 0.5 times 2, which is half of 2 is 1, so it's 0.5 feet cubed. And then to figure out how many of these fit in here, I got to divide them. And if I did that, I get 1.27, which means I'll need 2 containers. So the answer is 2. All right, that's going to do it for the video, guys. I hope you learned a few things. Thank you for the patience right here. And as usual, I'll see you in the next one.